Welcome to our flipped classroom for lesson 5.2, where we are going to be solving systems of linear equations by substitution. Now today in class we learned about systems of linear equations, and we learned that they are made up of two equations that relate to each other. So two linear equations that relate to each other. And in class today we learned how to find the solution by graphing those two lines. Well, tonight you're going to learn how to solve those same two equations, but instead of graphing them to find the solution, how you can use the substitution method. So I'm going to talk you through this. The essential question for tonight is, how can you use substitution to solve a system of linear equations? So I left you some blanks to fill in so that I could make sure you paid attention as I went through these steps. All right, and these are not steps you're going to find in the book. These are not steps you're going to necessarily learn from another teacher, but these are the steps that I try to give you to help make this process as simple as possible. All right, number one, you're going to label two equations, A and B. So you've got your two equations, label one of them A, label one of them B. Second, you're going to isolate X or Y from either equation and label the new equation C. So you're going to isolate X or Y, not X and Y. You're going to isolate X or Y from either equation. It's really going to be your choice of which variable you're going to isolate and from which equation. But once you've got that variable isolated, you're going to label that new equation that you've written as equation C. Now you're going to take the value of X or Y, depending on which one you found, from equation C, and you're going to plug it into the equation that you did not change. So you're going to plug the value of X or Y from C into the equation that you did not change. You can't plug it back into the same equation you just used. You have to plug it into the equation that you did not change. Number four, you solve the equation for what is now one variable. And number five, you plug the answer that you get in step 4 back into equation C, and you find the other missing variable. Now, let's take these steps. Hopefully they're right there in front of you as we work through these problems. But let's look at example 1. It says, use the substitution method to solve the linear system. Now, I just gave you 5 steps to use, but sometimes you're not going to need those 5 steps. So let me give you a few shortcuts and a few tips on how to speed this process up. If you're looking at a problem like A, where both equations tell you exactly what y equals, my question is this: if they both equal y, then don't the expressions equal each other? Think about it for a second. If both equations, if 3x plus 14 is y equal to y, and negative 4x is equal to y, then isn't 3x plus 14 also equal to negative 4x? Now, if you can visually see that, then that's going to speed this process way up. There's no reason to label anything A and B. The letter Y is already solved for. I don't need to plug it into the equation I didn't change. All of those steps are not necessary if both equations already equal Y. We just set the two expressions equal to each other. Now, don't call me after midnight is going to take me down to moving the variable. And normally I like to move the variable to the left side, but in this problem, if I move negative 4x, I have nothing left over there. So I'm going to move negative 3x. I'm going to bring down 14 equals, and negative 4x minus 3x is negative 7x. To solve this, I'm going to divide both sides by negative 7, and we always like the variable first. So x equals 14 divided by negative 7 is negative 2. Now, circle, don't box, because we're not finished. If you remember from our lesson today, the solution to these systems is an ordered pair, a place where the two lines would intersect if they were graphed. So circle, don't box. Now you have options. You can plug x into either one of the original problems. And I'm going to go with the second one because it's much less work. If I plug negative 2 into that second equation, that y equals negative 4x equation, I can quickly find that y equals positive 8, because negative 4 times negative 2 is 8. Now, if you chose the first equation and you plugged negative 2 in, 3 times negative 2 is negative 6, plus 14 is also positive 8. So either way, you're going to get the same answer. So there's no right or wrong place to plug that x value. But my final answer is an ordered pair. So -2, 8 would be my final answer that I box in. So make sure your final answer is an ordered pair. Now look at letter B. If step 1 is to label the equation A and B, and if step 2 is to isolate one of them for x or y, look at letter B. What jumps out at you? If I'm looking at this question, I can see that the first equation already has x isolated. So I'm going to take that value, that expression, and I'm going to go ahead and I'm going to plug it into the other equation. So 4, now remember, I'm replacing x, so I'm going to put a parenthesis, because when I plug things in, I always plug them in parentheses. I'm going to plug in 6y minus 7 because that's what x equals, and then I'm going to bring down the rest of the problem. Don't call me after midnight. I'm supposed to distribute first, and right here there is distributing that I can do. So 4 times 6y, and I'm going to do 4 times -7. So 4 times 6y is 24y, 4 times -7 is -28, and then I'm going to bring down the rest of the problem. Call, the C stands for combine like terms. Hopefully you see very easily 24y and positive y are like terms. So when I combine those, I have 25y minus 28 equals -3. Don't call me. The M stands for moving the variable, but in this problem I only have one variable, so I don't have to move it. That takes me to after or adding and subtracting. So I'm going to add 28 to both sides. I'm going to bring down what I have not used. And -3 plus 28 gives me positive 25. Now, if I divide both sides by 25, sorry about that, I find out very quickly that y equals 1. Now, circle, don't box. I, again, have options. If I go back up to that original problem, I can choose either of those original equations. Now, I'm going to choose the first one because x is already by itself. So all I got to do is plug in that y, which is 1, and do a little bit of math. So 6 times 1 is 6, minus 7 makes x equal -1. Circle, don't box. And so my final answer, I'm so sorry that I ran out of room, but my final answer is the ordered pair -1, 1. Now, there is a way to check these, and I'm going to show you that in a couple of minutes. But for now, final answer is an ordered pair. Now, these are shortcuts. Whenever both equations are set equal to the same variable, or when at least one equation is already solved for a variable, we really can skip through a lot of those steps that we just wrote down. But what happens when you look at a problem like this and neither equation is solved for one of the variables, neither equation or both equations are not set equal to each other? What do? Well, I have a decision to make. And in example 2, we're just going to simply decide which equation you would use to isolate that variable and why. So I want you to pause for a minute. I want you to look at A and B, decide which equation you would use to isolate a variable, and tell me why you would choose that equation. Now, this is my thought process. Hopefully you've taken a minute. When I look at letter A, I'm immediately looking for an equation that has a variable with a coefficient of 1 or -1. So if I'm looking at letter A and I'm looking at these two equations, I notice pretty quick that this first equation has a variable of x and the coefficient of x is a 1. So I would choose equation 1. And why? Because it asked me why. Because x has a coefficient of 1. When the coefficient of my variable is already a 1 or even a -1, it makes solving for that variable much easier. Now, when I look at letter B, again, I notice in the first equation that I have the variable y, and it has a coefficient of -1. So I'm going to solve equation 1. And I'm going to do that because y has a coefficient of -1. Now, I don't love -1s, but it's better than having a -2 or a -5. So that would be my reason. I'm looking for an equation that has a variable that has a coefficient of 1 or -1. Now, let's look at example 3. We're simply using the substitution method to solve the linear system, but we can see very quickly the shortcuts aren't here. All right? One of the variables isn't already solved for. They're not both equal to the same variable. So I'm going to have to actually work through steps 1 through 5. So let's go through this slowly. I'm going to label the first equation A, and I'm going to label the second equation B. I'm going to choose which equation I want to solve and which variable I want to solve for. So I'm going to go ahead and use equation A, and I'm just going to pull it right over here to the side. All right, and this is how we're going to keep our work organized. So pull it right over to the side, and then go ahead and cross out the A, because we don't want to try to use it again in a little bit. So let's go ahead and cross out that A. Now, I'm going to solve for X. Could I solve for Y? Absolutely, but I'm going to solve for X. So I'm going to subtract Y from both sides, and I very quickly get that X equals -Y minus 2. So I'm going to circle, not box, and then I'm going to label this as equation C. All right, that's what step 2 tells me to do. Isolate X or Y, I'm isolating X, and then label the new equation C. Now that takes me into step 4. I'm going to plug the value of X into the equation that I did not use. So what equation did I not use? I did not use equation B. So I want you to draw that arrow on the notes. When we get to tests and quizzes, it won't be necessary, but for our notes, I want you to see you took that equation, and where did you plug it? You plugged it into equation B. So -3, I'm replacing X, so I'm putting parentheses, and what did X equal? It equaled -Y minus 2. I'm going to close the parentheses, and I'm going to bring down the plus Y equals 6. I'm now going to follow Don't Call Me After Midnight, and I see the distributive property. -3. Now -3 times -Y, when I multiply two negatives, I get a positive. So 3y, and -3 times -2 is a positive 6. And then I bring down the rest of the problem. I quickly see my like terms of 3y and y. And so 3y plus y is 4y plus 6, and it equals 6. I'm supposed to add or subtract, so I'm going to subtract 6 from both sides, and 4y equals 0. I divide both sides by 4, and y equals 0. Now, step 4 says to solve the equation for the variable, and that's exactly what I did. I solved my equation for y. And the last step is for me to plug my answer back into equation C. So again, just for the sake of our notes, let's draw ourselves an arrow. Where are we plugging the y equals 0? We're going to go back to equation C because it's going to be the easiest way to find out what x equals. -0 minus 2 makes x equal -2 when I do the math. Circle, don't box. And my final answer is -2, 0. Now, I'm not going to require you to check, but let me show you how you can check. Remember, we learned today in class, if you take a point and you plug it into both equations and it makes both equations true, then it's a solution. So we would take x plus y, we would take 0 minus 2 equals -2, and -2 does in fact equal -2. So it works in the first equation. I would then take the second equation, and I'm going to do -3 times 0 plus -2, and it's supposed to equal 6. So let's see if it does. -3 times 0 is 0. Hold on a second. If we were all together right now, I would hope that you would be yelling at me that I put the wrong numbers in the wrong spot. So let's try that again. -3 times x would be -3 times negative 2, and the y is 0. So negative 3 times negative 2 is 6, plus 0 equals 6, and 6 does in fact equal 6. So it works in both equations, so we know for sure that negative 2, 0 is our final answer. So while I'm not going to require you to check it, for those of you that want to make sure that your ordered pair is correct, that is how you would check it. Now, take a minute and work letter B. Same thing, if I look at this, the shortcuts don't exist. I don't have a variable already solved for. They're not both set equal to the same variable, so there's no shortcuts here. So take a minute and work this one out on your own. Follow those 5 steps. Hopefully you went ahead and labeled the first equation A and the second equation B. Now, just for fun, let's do equation B this time. Because really I could do A or B for y, but I'm going to take 3x minus y equals 1. And remember, we're going to cross out the one we chose so we don't try to use it again. Now I'm going to solve for y, so I'm going to subtract 3x from both sides. And look, here we are again. This is something we learned in the very first chapter. How do we put a problem in slope-intercept form? That's really what we're doing here. So I bring down the x term first, bring down the constant, and there is an understood 1, so I am not finished till I divide everything by negative 1. So y equals 3x, because a negative 3 divided by a negative 1 is positive, and 1 divided by negative 1 is negative 1. Now circle, don't box, and label it equation C. Remember, I'm taking the equation and I'm plugging it back into the problem I did not use, which in this case is equation A. So I'm bringing down equation A, which is 2x minus, and in place of y, I'm plugging 3x minus 1, and then I'm bringing down the rest of the problem. Now be very careful, because we do have the distributive property, and it's right here. There is an understood 1 with that negative sign. So when we distribute, it's not 2x we're distributing the negative 1. So negative 1 times 3x is negative 3x, negative 1 times negative 1 is positive 1, and we bring down the rest of the problem. Combining my like terms means I'm combining 2x and negative 3x. That's negative 1x plus 1 equals negative 5. I'm moving the 1, so I'm subtracting it from both sides. Negative 5 minus 1 is negative 6, and I am dividing both sides by negative 1. So x equals 6. Circle, don't box. Remember, once I've solved for the variable that I chose, I'm plugging it back into equation C. So y equals 3 times 6 minus 1. So y equals 18 minus 1. So y equals 17. My final answer is my ordered pair 6, 17. And again, if you would like to check it, feel free. Now, everyone always likes to know, when am I going to use this in real life? So example 4, we're going to write a system of linear equations, and then we're going to solve by substitution. So there are a total of 64 students in a drama club and a yearbook club. So we got 64 students. Some of them are in drama, so let's use D, plus some of them are in yearbook, but we know together we have 64 students. So there's equation A, super simple. Drama club plus yearbook club equals 64 students. Now it says the drama club has, so D equals, because we're talking about what the drama club has, it has 10 more students than the yearbook club. So we know Y represents the yearbook club, and if it's 10 more students, that's addition. So 10 more students is addition. Now, hopefully you see right away the shortcut. Equation number 2 is already solved for D, so I get to go right into plugging that into equation A. So in place of D, I'm plugging Y plus 10, and then I'm bringing down the rest of the problem, which is plus Y equals 64. I am combining my like terms of y and y, which gives me 2y plus 10 equals 64. I am subtracting 10 from both sides. 2y equals 54, and I am dividing both sides by 2. So y equals 27. That means there are 27 people in the yearbook club. Now I'm going to take that and I'm going to plug it right back into this equation because D is already by itself. So D equals 27 plus 10, which means in the drama club I have 37 students. So my final answer is 37 drama students and 27 yearbook students, or something to that effect. If you want to say there are 37 students in the drama club and 27 students in the yearbook club, that would be perfectly acceptable. But somehow you've got to make sure you label the two parts. So we're not doing an ordered pair this time because they want to know how many students are in the drama club and how many students are in the yearbook club. So we're just going to write these out and label them because it is a word problem. And that is how you use the substitution method. Have a wonderful night, and do me a quick favor. Go back to example number 1. Right next to the instructions on example number 1, I want you to write down your favorite Halloween candy that you got last night. Have an awesome rest of your night, and I will see you tomorrow.